So if I say trillion, it means we're talking about 24. And then 100 is 20. So 10 to the power of 26. The universe is expanding massively. Now, the reason for this theory was the fact that they observed that. So I told you this is quite messy. It's you make an observation and then work backwards and understand what's happening. And they try and find evidence for your thinking, for what you are guessing, what you're hypothesizing is happening. So what they found was that the universe was flat, rather than spherical, or, it was flat in how it expanded. And also it was quite uniform. And then there was an element called cosmic microwave background, which is also quite uniformly distributed. So back in the day, let me tell you what cosmic microwave radiation is. Back in the day, some of you are too young to remember this, but back in the day, there was only one channel on TV, which was KBC. And then later, there was a second channel called the Kenya Television Network. So when you turn on the TV, right, there will be this static so this grayish matrix on the screen. And that's because the TV has a detector to pick up radiation, to pick up waves. So that static that you're picking between channels or before the TV channel, because the TV used to come on, was it 4 p.m. with the national anthem? So that static sound is your TV detecting that cosmic microwave background. And what is it? These are microwaves that are a relic of that explosion. I'm not going to get into it more than that, but the point is, it started off as a light wave, but as it has traveled through time, the wavelength has become so long that you can no longer see the light. It's now become a microwave, which you can detect by that TV. And there's an interesting anecdote how the cosmic microwave background was discovered. The point of all this is we started with Planck time, density, and then we went to the forces that were acting that time. And then we went now and looked at the disintegration of those forces and continued expansion and cooling in this inflation. And how this inflation, cosmic inflation theory came about was because of the observation that was made that the expansion of the universe is quite smooth and it is quite uniform. So no matter what direction you're looking at, you can pick up this cosmic microwave background, meaning it is not coming from any one source. It's a relic from the Big Bang. Now, at this point, I want to take you back to two things. Number one, I want to point out the scientific methodology. So you observe, you come up with a theory and the mathematical formula to back up your theory. And also you perform experiments where it's possible to confirm your theory and also to make predictions. If your experiments and your equations are not matching up with what is observed, there is some kind of problem and the theory needs to be modified. Likewise, if your theory and your mathematical formulations or your experiments cannot predict something else, then that also needs modification. So there's always that constant dance and addition of knowledge and modification. It adds to the complexity, but it also makes it more interesting, number one. Number two, the fact that the universe was expanding, because how did we start with this infinitely small, it sounds like someone just pulled it out of nowhere. Not really. Because when you look out of a telescope, Hubble telescope, you look into the distance,